Hello, everybody. I'll let you 1 minute for people still coming in. Okay, let's start with that. If you miss it, it's not a big deal. So who am I? I used to be a developer, so I don't have a hacker background. I work last 12 years in the area, mainly coding for security solutions. And I really focused on mobile. I know it's been 8 years. Now OWASP Geneva co-chapter member. And I work for my own company. So basically, I give some consulting to help companies write less insecure code. Let's say it like that. But I don't deal at all with GDPR. If anyone has question about GDPR, ask Stefan. Okay, so what we are going to talk about. First, quick word on what's Android in-app billing, and then why I will talk to you about that. I want to show you that it's possible to rather easily steal some credits in video games with just simple Java reverse engineering. I will show you how to do that with a one-liner hook. And also show you, after this hooking, how you can even repackage the application and then resell it if you want. And why this model is bad. Then I would like to take some time to explain why it's possible and basically why the design of Google is bad. And then provide some recommendations, and we'll have a quick look at, for example, what's doing Angry Birds to have something somehow secure. Yeah, Java reverse engineering is a real threat for those Android applications. Most people say, yeah, we don't really care. So people start to care when there is money at stake. So for that, there is a perfect target, what's called the Android in-app billing features. So basically, it's an API for Android developers so that they can sell content directly in their application. So it's a copy of what proposed Apple first. So basically, you're in your free application and you can decide to subscribe for magazine or pay for premium features or decide to buy some bonus content or whatever in the game. And what does Google? Well, Google handles all the payments. So as a developer, you don't have to handle any credit card or whatever. Google does that for you with a big fee in exchange. And all that is handled via the Google Play application. And they say, yeah, now it's super secure because you don't have to handle with credit card and Google is doing the security of the transaction. So it should be safe. And that's why they take money. If there are brave people, you can have a look at their documentation on the bottom link here. Dozens of pages. And the most unclear part of it is this ugly diagram, which is not up to date, and the API today is not working like that, but it's not being updated for years. Even myself, I know the system. Each time I reread it, I don't really understand what's going on. So basically what they say is, okay, you have your application here, you have the Google Play app, and there will be exchanges of data. So to make things easy, basically from your game here, you call an API that say, hey, user wants to buy something, and the Google Play app takes the front screen and does all the job, and in the end, it gives you an answer with a signature that says, hey, I confirm you that this user bought this feature, and here's a signature that proves that it's real. I will show you just after in a real game how it looks like, because it's really blurry. So for that, I'm using what was a rather popular game, now far from the top 10. And they did in-app purchases so that you can have new weapons and extra lives. So the first thing I will do here, because I will get the APK file rather than downloading it on a mobile and then trying to censor it. I just take it from website that mirrors the Google Play stores. Really don't use it on your personal smartphone. You don't know what can be added in this kind of packages. So be careful with that. And then the first thing we will do, we will prepare an emulator. And for that, I use a Genymotion one. Not working anymore. Because it's really, really fast compared to the emulators that's provided with Android. And you just have to do one click and then you get root on the device, which is really convenient. And there is a free version available, but you have to look deeply in their website so that you see that there's a free version. And then what you need, because they come with a custom ROM that can be rooted easily, that's x86 architecture, so that it's really fast when you run it on a laptop. You don't have the Android application on them, so you have to install what's called OpenGApps. But with Genymotion, again, it's a one-clicker. So with that, you get the Play Store application, Gmail, and Google Maps, and whatever else you need. So the only constraint to be able to use those in-app payments is that you must sign in with a valid Gmail account, because at some point, Google will authenticate you and will have a look at your Google Play account and see which credit card is associated to it or whatever. Okay, so now I just show you how it looks like in real world. So you have your game here, and at some point you want to buy some content. So here I'm in the game, I say plus, I want to buy some extra coins for those games, and they tell me, yeah, it's 1.5 francs. I click on it, and then now you see, now the pop-up here, this white screen, it's not a game anymore. It's a Google Play app that will do all the interaction. Of course, for this demonstration, I'm not going to continue. I'm not going to pay for that. Okay. And then, yeah, he's not happy because I didn't pay for it. Okay. So now we have everything ready for our exploitation. So first thing we do, well, we just take this APK file and we will use a free tool that's called JEDX. It will decompile it rather quickly. It's between 2 and 3 minutes for this game, and it will display almost the corresponding Java code in an EDA fashion. And it's really convenient because you see really the full Java code and nothing special to do. And what's interesting, in those dozens of pages in the documentation of Google, they say, hey, you have to do something. Yeah, you should use ProGuard. But at one point, they say, yeah, you should add an exception to be sure that all the classes that are named com.android, vending, then billing, those classes, you should not change their names. Otherwise, it's not going to work because Google is not, you will not be able with their API to trigger the Google Play app. So for that, you're sure that in your app, you will have full strings called like that. So the only thing you have to do, even if the application is obfuscated, you know where to look at because you know this is going to be clear text. With our application, it's even easier because in this game, they didn't obfuscate anything. So it's good for training. So with that, so I go searching for those vending classes, and then I have a look at the source code. And then I found something interesting. At one point, they use compare it. They use a special value android.test.purchase, but there are comments in the source code. So those guys, they published a game, they deploy it on the Play Store, and just by reversing it, you get the debug instructions. So that's really funny. And what's the comment here? I do some code reviews for my work, and most of the time it's not funny doing a code review, but this one was, yeah, rather fun. And they say what they do here, they had a special case because they say, hey, we are fixing a Google bug. So those guys, they are doing their own games, you see, with pandas and whatever, and they think that Google has a bug and that they fix it for themselves, and that Google is not capable of providing an API that's working. So for me, it rings a bell and say, hey, yeah, let's dig here. So hey, what's this android.test.purchase value? So well, you Google it, and you find something in the middle of those many pages of documentation that says, yeah, in the testing, yeah, if you use this value, it's as though you successfully purchased the item. And then it says, not here, but you don't get a signature, but it's detailed. But what it means that Google decided to have a test value, and it will be always valid even in production. So that's really crazy design by Google. How do you let a test value live? It's just nonsense for me. But yet they did it, and here the guys that developed those games, they even use it, so it really smells bad. So yeah, what do we do? Okay, so well, we'll try to use these special values. For that, we will use hooking, and with something really simple. So in the source code, there's a method that's called purchase product. In input, you have what's called the SKU. SKU is serial number, so basically it's what you're going to buy. So it's, I want to buy the compact one, for example. So, and what we are going to do, we are going to force this value to android.test.purchase, and we see what happens. For that, we can use, to make things easy, we can use a hooking framework like Xposed. So what it does, I will show you just after. You install it on your emulator, and then it intercepts all calls on the virtual machine. So basically, you can redefine the classes, any classes of your operating, of your Java operating system here. What's really interesting is you don't change anything to the application or APK file. You just change the behavior of the virtual machine. So you load in the virtual machine the code that's good for you. And so what it means in practice, you start a new Android Studio project, and it gives you a new application, and you deploy this new application that will somehow overload the original application. So for that, to be able to do so, of course, you need a rooted device because you are playing with the virtual machine, and yeah, please use it only in an emulator. Some people try and also advise people, and they still deploy it on their own smartphone, and then they broke them, and it was bricked, and then that's over. So just please use it in an emulator. And so for that to be able to install it, that's really also easy. You have an APK file for Xposed. You just drag and drop, reboot the emulator, and then it's ready. So we will do the exercise right now. So what a hook looks like. I'm sorry, this is really small. I didn't find out how to zoom. We won't go into the details. I'll show you there, it's better. So basically what we say here, we say that we want to hook the method that's called purchase product. I just do some logging, and what's really important is just this line. I say that for the method purchase product, I change the parameter 0, and I force it to android.test.purchase. So it's just those few lines of Java. We will compile them. So we will build it, and in the meantime, okay, I get my hook, which is an independent application. Then I go in my emulator. So you see with Genymotion, that's really easy. To install an APK file, you just have to drag and drop. Okay, and now Xposed say, hey, you install something new, but it's not activated, so we will do so. I will kill this game. Okay. So my hook is here. I will activate it. And it tells me that's what's annoying with those hooking frameworks, because it hooks virtual machine rather low at the boot process. Each time you change a hook, you have to reboot your virtual device. So that's why you really need something that's fast as an emulator. And why is it done so? Because most of the parts of the UI of Android, it's written in Java. So you can also hook that. So the hooking framework has to be loaded really, really at the beginning of the boot sequence. So I have to reboot. So I will do so. I started. So here you see I'm using a Android 7.1 version, so it's something rather new. So we have to wait a little, and then we see what happens with this hook. Okay, so now I start the game, and things will get slower because now the hooking framework is activated. So each time a new Java class has to be loaded, it would first go through my hook to decide if it has to load the real class or my own implementation of the class. And if you start writing many hooks or hooks that are slow, your operating system gets really, really slow. Okay. Sorry for that. You see I'm using the free version. So there is one free version, but you have to find it. Okay, so now what I do, I say, yeah, I want to buy extra coins. I'm in the game, okay. I do that. And now, what do you see? Well, first, it's not francs anymore. It's $0.99. And you see a card number, a credit card, which is called Visa XXX fake. So this is production data. So this application was published on Google Play Store and whatever, but still, and you can contact Google and ask for them with production system with a fake card and say, yeah, sure, let's buy it with this fake card. I'm not gonna pay anything. Google says it's successful, and normally it should be rejected by the application, but no, of course it works. So that's it. Now I get some free credits. I can buy whatever. Yeah, this one is good, 30 francs. Yeah, let's get it. Yeah, sure, I want it. And voila. Okay. So now, why is it working? So yeah, we deploy this hook and whatever. So what Google documentation says that when you're using this fake credit card, you don't get any signature in the response. So the game normally is responsible for checking the signature from Google to be sure that it's a real purchase. Okay, so clearly this is not done, otherwise it will not work. So let's have another look at the source code. Let's have fun again and see where is done this check. And well, it's rather easy. So now you just have to look for android.test, android.test.purchase right in the source code, and they have a big while liner where they test if they should do the signature or not. First, they have a value that's called auto-verify signature, which is meaning I don't do anything. And there is also another test which is, yeah, easy to test SKU. And test SKU is, does it start with android.test? And if it's so, yeah, if either of those two parameters, yeah, let's say it's successful and don't verify any signature, and then that's it. So that's really bad. Okay, that's why it's so easy. We will discuss afterward that even if they verify the signature, we can still bypass it. But that's just crazy that in a production game, there are test values in the files, there are logs that say that they use the test value and that Google accepts them. Okay, so now we are happy. So with my emulator, I can play for free, but you see it's rather slow. And if I want to give it to whoever in my family, it's not convenient because they can't really use it on that smartphone because they have to install this hooking framework and it gets slow and whatever. So what we're going to do now, we are going to repackage the original application and then changing this source code so that then people get a nice APK and they can install it on whatever device. So what we are going to do, thing you have to know, so you don't have directly Java bytecode running on Android, so you your Java source code, which is compiled to Java bytecode, which is translated to what they call Smalley bytecode. So it means we will have to rewrite some Smalley bytecode. And so what we are going to do, we are going to get this Smalley, the code of the bytecode of the original class. We are going to get the compiled code of our hook, so the second APK file we did. We will see what's inside, and we will just manually patch and inject the content of this hook, install the original code, and then repackage everything, and it should be it. So we'll do that right away. So for that, first thing, yeah, you have Java tools like APK tools that will get your Smalley code right away. So we will just go through the sequence right now so that you see it's really not a big deal. Okay. So let's do it live. Let's take some risk. Okay, so now I'm taking the APK file, and with the APK tool, it will produce all the Smalley files, so all the Smalley bytecode. Okay. Okay, so now it's been converted to Smalley bytecode. So now I will edit it. So here, what I have to do, I have to look for the purchase product method in it. It's here, so I don't know how I can zoom. Yeah, I will do it. I just do some copy paste. So you better see how it looks like. Okay, so what does Smalley looks like? So so it's not easily readable like Java, but you can still get a clue at what's going on. So you have a public method that's called purchase product that takes a class that's called string in Java in input, well, 2 strings in input, and then you have the names of the input parameters. Then a prologue which says this is the beginning of the class. So it's something I really wouldn't like to code with this language, but when you have to read it and just change one line in it, it's not a big deal. So what I'm gonna do again, so I will just add one line in it. And I see here. So the only thing we have to do, just after the prologue, we add one line that says, yeah, well, in fact, we change the input, we force the parameter 1 to android.test.purchased. And when you do that, okay. So now what we have to do is to recompile everything, repackage it. It's where things get a bit messy because Android games, they can be just Java, but most of them now, they have C libraries, everything for graphics and whatever. They have some extra libraries, and those libraries are not well handled by those APK tools. So an APK file is a zip file, so we will handle the zip file manually so that we just change the Java classes in them, and then we will sign it manually, and you see how we do. Okay, so now, yeah. Quoi? c'est où? Hop. Okay, so what I'm doing right now, I'm recompiling the Smiley bytecode. So I had this APK file, which led to via reverse to Smiley bytecode. Now I'm converting back the readable Smiley bytecode to something that's executable for Android. So in an Android APK file, everything is in a file that's called classes.dex. So it's all the Java compile stuff is here. So I recompiled the Java stuff. So now I update my zip file with this Java stuff. And then now what I have to do, because of APK file, there is a signature in it. If I try to install the game right now, it's not gonna work. So what I do, I delete in the zip file the current signature, which is in this meta.inf folder. And then I'm gonna resign it by myself. So for that, I'll create a dummy key certificate. Okay, let's see, it's whatever name, whatever, I don't care. Yes. Yes. Okay, so I generate a new signing key. I will sign my APK file with it. Okay, need the password of my super private key. Okay, so it's resigning all the dependencies, and it will be resigning also all the libraries and whatever. You didn't see it, but in the middle of that, there were DLL files. So you have to explain me why they package DLL files for Android games, but it's there. And you see why it's so crappy. And here you see that there are some Unity SO libraries, so some Linux libraries there. And now, yeah, I just want to cross-check that the signature is valid. So I just check locally that it makes sense. And then, okay, I have some warnings, but it tells me they are verified. So what I do now, I start a brand new emulator, this time using Android 8. So supposed to be the latest version with all the security features and all that. So it should be totally bulletproof. Really slow. You have some bugs sometimes with Genymotion. With Android 8, it's so I have to restart it. Suspense. Always something going wrong with the demo, you know. Okay. Let's keep it in background and we'll discuss, and then if it starts, I will show you. Okay, so what we did. We directly inserted just this one line. We recompiled everything, and we did a signature. And then I say, yeah, so now with what we did, you could even decide to publish it on the Google Play Store and now try to sell this game. And it's signed by your own signature. Maybe you just change the name, and then that's it. And then people say me, yeah, well, yeah, maybe this works with all versions of Android, but since Android.7, they have a version 2 of signature, which is supposed to be far more secure and to check everything. But yeah, but what they did, when they decide if a signature is valid or not, well, for legacy purpose, you can have APK files. So currently you can have games on the Play Store that don't have the new version of the signature, that still have the old one. It's what they do from Android 7. They say, hey, do I have a new signature? If yes, I try it. And if I don't have a new signature, a new version of the signature, I will use a legacy mode. So that's exactly what we do. When I do jar signer by hand, I just sign it with just a version 1 signature, and it doesn't cause any issue with the brand new versions because they think that it's an old version of the game and that, well, it doesn't provide a V2 signature. Yeah, I just check the V1 and the V1 is working. Has it started at some point? So slow. Don't know why. Well, okay. I will show you just after. Okay, so what we learned there? Yeah, first, you should never let your debug code in a production app. So those logs, that's crazy. Especially when it's more than debug log, but it's really, you have test values and you get them hard-coded in your apps and it goes live. That's really bad. But for me, even worse is that, yeah, Google, they accept this test value in production. That's really crazy. And there is really something that's wrong and it's insecure by design because the client, so the Android game, decides if the signature is valid or not. So you're always gonna be able to hook it. So I showed you it works because it was a test value, but they were also checking the signature. If I just hook the signature method and in the implementation, I just say return true, it's gonna work also. And for that, I don't think Google are really honest because their documentation is misleading. So they have something they call best practices. It's somehow how to do it less messy. So there is a big chapter which is validating purchase details. And they say, hey, it's highly recommended to validate purchase details on a server that you trust. So yeah, okay. If you check it locally on the game, you always have issues because you can do hooking. But if you cannot use a server, you say, hey, you know, a server is really expensive today with the cloud and whatever. You are poor game developers, you cannot buy any server. If you cannot use a server, it's still possible to use it. So somehow, let's say now you have a great project managers, and project managers say, hey, it's not going to be secure. But you say, oh no, Google tells me that that's okay. It's not that good, but that's okay. Yeah, please proceed. Again, so at another part of the Google documentation, which is really, really messy, they say, hey, this verification isn't truly secure. When they say, hey, so you have to validate the signature, but yeah, maybe it's not as useful because if someone wants to bypass it by changing the logic of your app, then that's game over. And what's their recommendation is, yeah, you should obfuscate it. Yeah, but you remember what I said at the beginning? They say, hey, don't obfuscate those class names because otherwise it's not going to work at all because the API won't be able to do the matching. So they say, hey, do obfuscation, but don't do obfuscation over on classes. So because you don't obfuscate the API link, you know which obfuscated class is directly calling it. So it's really super easy to find out. So for me, it's a bit a joke. But what's even worse is, yeah, for me, you can't use in-app billing to buy credits. Originally, it was designed to purchase some new content. Let's say you are buying a new magazine. You cannot guess this content. You are really buying the data of this magazine. You are not just buying an incrementation of a counter. If you are trying to increment a counter, it's easy. Via hooking, you just have to find the method that has access to this counter, you call it, and then that's it. That's game over, and the counter is in the game. You can increment it, and that's finished. But what I really dislike Google here, again, in the middle of all those pages of documentation that no developer reads because it's really boring, they say in the middle of it, hey, you can implement consumption for products, blah, blah, blah. For example, the user in-game character might gain life points or gain extra gold coins in their inventory. So by reading that, you conclude that, yeah, well, Google tells it as an example. So yeah, I should really be able to sell credits via this in-app billing because Google tells me so. So their documentation is almost lying there. So it's really annoying. And they say, basically, when you read that and that, they say, yeah, I just want ProGuard with the advice they gave me and it should be fine. Wow. I show you the app right away. Of course, I contacted the editor. As often, no one cared. So first, I contacted the editor of the game. I never got an answer. I think now they are not making much money out of this game anymore, so they just don't care. But what was interesting, if you have a look at the class name, the package name, you see there's the package name is com.prime31. So who they are? In fact, it's a company that's selling integration plugins for Android. So some helpers. So I discussed with them. They have a ticketing tool and they answered me rather quickly, like one day. And the answer was, yeah, this vulnerability doesn't make any sense. Well, if you want, well, you're selling a plugin to sell content. I can have free content, and you say that doesn't make sense. Okay, so I was a bit pissed off, so I decided to push further. And then I said, yeah, I don't agree. And I said, yeah, the developer should be checking the SKU of the project. Okay, so I was really unhappy. So what I say, okay, now support doesn't really want to talk to me. So yeah, I'm gonna be a customer of this plugin. So I buy it, $70, rather expensive. What I get for that, I just get a download link, and then that's all. And then I realized that, in fact, so it's a Unity plugin. So Unity is an engine to program cross-platform games. So you write your game in C#, and then you can compile it to Android, iPhone, Windows, whatever. So that's why you get those DLL files in the APK file, for example. And so what they did, they made a C# wrapper on top of the Java Android API. So you're a game developer, you just write C# and you have some methods to call the in-app billing features. And of course, I'm a customer, so I think I will receive some documentation on how to integrate it because I paid for it. What's a doc? Well, it's just a link to their public website. So basically, it's just website/docs. So that's what you get for the $70. And that's funny because in the middle of that, you have something where they say a paragraph, they say, yeah, purchase validation. Google highly recommends always validating purchase on a secure server. The plugin will do on-device validation for you, but Android apps are very easily hacked, so this should not be relied on. So sorry, you just bought a plugin, we know it's crap, people are gonna bypass it, but well, bad for you. So I contacted them again and said, you plan to do an update and whatever. I never received any answer, and now it's been months, and I've never been notified if there is an update on this plugin. So they're selling a plugin and you can't even get updates because the only thing I receive is a unique download link. So I cannot even update this library. This is just crazy. And yeah, so I didn't have any answer. So at one point I was curious, hey, now I'm going to a conference. So yeah, I send you the slide and maybe you tell me if it still does not make any sense. And he said, yeah, many thanks for that. I look forward to reading them today. And then, well, it's been dev null for months. So just doesn't care. I don't get any fix. So that's really bad. So, okay, so now what you should do if you want something that's a bit more reliable. Well, first, you don't work with those guys from Prime 31. Second point, yeah, you can use ProGuard, you obfuscate it, and it will slow down an attacker, but it won't hide the call to the APIs. So for me, it's just leave on 0. So what you can do, you can use the native development kit of Android. So basically, you can write C code for your application, and it's using GNI, and you see some methods that are called natives. And for that, if someone wants to do reverse and patch the binary code, it's another challenge, especially you have to know ARM and all that. Second one, yeah, say as Google, use a backend to validate the purchases. But yet, if you are still buying counts with that, it's not gonna work, because let's say you have your app that's talking to Google Play answer, yeah, this user just bought for $10. Here's the signature, you take the signature, you send it to your backend. If the backend just says, yes, no, this signature is valid, what you're gonna do, you hook the logic that receives the response of the server, and you say, hi, server tells me, yes, it's valid. So it can't work. So the only way that it can work from a secure point of view, you have to sell real content. So you have to sell something that's not guessable. You cannot sell a counter. Angry Birds is a good example for that. 3-4 years ago, they got caught for something similar. And now what they do, so you are not buying extra lives. You are buying new levels. So you are buying level design. So you are buying data. You cannot design by yourself new levels. So that's what you're buying. So what they do, you pay, you get this answer from Google with a signature. The Angry Birds application sends that to the Angry Birds backend. The backend checks the signature, and if everything is fine, it provides you the full content of the level. Otherwise, you get nothing. So in this case, it works, and they also use NDK. So for example, if you try to decompile this Angry Birds application, you see that there's a method called payment finished and no implementation in it because it's native, so everything is done in C code even. So they use all the methods together. And as it started meanwhile. Yes, it has. So I have a brand new Android 8 here without any hooking framework. So it's fresh new install. I just installed a Google Play with open gaps. So, and if anyone wants the APK file, I can provide them. So just installing it, running it. Hey, it's starting. So it didn't complain at all because I changed the signature or whatever. So it just starts. You discover what's the goal of the game now, because I have to play the introduction level because it's the first time I install it. Yeah, you get it. So some people pay 30 francs to get some extra content or whatever for that. Okay. I should have wrote a hook to bypass this first level. Okay, yeah, well, whatever. Okay, so yeah, we are saving pandas. Okay, that's it. Yeah, well, blah, blah, blah. And you see now the emulator is rather fast because I don't have any hooking framework. So it's really full speed now. Okay. Blah, blah, blah. Okay, next level. And then, yeah, it's really too difficult for me. So I need some extra content and help for that. So I'll buy coins. Yeah. Again. Of course, it works the same way, but without any hooking framework this time. So now, yeah, you can sell it to whoever you want, and I could even publish it on the Google Play Store. And maybe if PandaPop is not doing good monitoring, maybe it takes them weeks or months to realize that there is a clone of the application running with free content. Because from a Google point of view, there is no malware in this application, it's just legitimate. Now you imagine what you can do, let's say, with an e-banking application. Okay, so conclusion, yeah. So I just want to show you, yeah, with Jadix, you take the APK file, you put it, you wait 2 minutes, you get the Java source code, and that's it. Of course, yeah, you cannot trust the Java source code running in your app. So modifying it is easy, and resigning it is easy. It's really a piece of cake. So The Android signature is a joke because it's just a self-signed signature. The only thing they protect is when you deploy on the Play Store, and as developer one, I published it for the update. If the signature, if the key used is different for version 2 of your app, the update is not going to work. So they are just protecting the update scheme to be sure that the update received comes from the same company. But they are not leaking at any time a game, a package name with a key or whatever. So you can do whatever you want. Because you can only trust what happened on the server side. I really am so disappointed by the Google recommendations, because if you read them, you think that, yeah, you can do in-app purchase. Well, if you validate it locally, it's not that good, but it's okay. And if you obfuscate and doing on a server, it's bulletproof. But most use cases, it's just not possible to secure them. So the only thing that makes sense is something like Angry Bird, where you download unpredictable content. Does anyone have any question? Otherwise, I have some bonus. Yeah.
Hey, many thanks for the talk, Jérémy. I have two questions. The first question is if you have found, let's say, Android games using like native code and using, for example, Java reflection at the Java level and going over GNI bridge to the native code and using it. And the second question is, as far as I know, suppose it doesn't support native hooking. Have you considered, for example, using Frida? If you have, for example, found another application? And yeah, thank you.
Yeah, so I don't think I will really answer like that, but yeah, there are people that are using reflection, but it's not gonna work well. Basically, the API/SDK of Google is not gonna work as is, because they expect to have the correct class and class name and whatever. So if you really want to use in-app billing, and you try to use reflection to hide some stuff, it's gonna get hard because the classes are not going to be instantiated as they should. So difficult. And then, yeah, the question was about native hooking. That's it. I'm a bit lazy. I don't want to go to reverse some ARM code or whatever, but what you have to know is you see there's this native method, so you can always hook the inputs and outputs. And because you control the Java code and the Java code is doing all the UI part, you can hook whatever you want in the UI part, so you can really change a lot of things. So really for this in-app billing stuff that's using a Java API to call Google, it's you could try to call it from C code, but to try to reinforce it. But I think you are going to take a long time to get this API running from the C logic.
Thank you. I'm not a developer, but are you sure that it's not possible to do it over reflection?
It should be, but then there are lots of classes that won't match and whatever. So it's why they say don't change it in ProGuard. Otherwise, you're going to make a lot of.
And the first question, have you found more applications? Can you say names of games? Or?
No, I don't want. This one I can because there's responsible disclosure behind, but something that's really easy, you go to those APK mirroring files, you go on the top 25 game sections, and you just search for vending.billing, whatever, and then you get all of them. But you know what's the most difficult, and I can tell you from my own experience, is trying to find where in the game or whatever there is this feature. Where is the menu to do that? Because sometimes it's so messy, there are things everywhere. You don't know if you are where you can really buy content. You know in the source code you can, but it's more difficult to see how can you really steal it because you just don't know what it's used for.
when you talk about purchasing levels like in Angry Birds, which mechanism prevent from copying data from another account and fetch them into your game?
None.
Okay.
No. They just suppose that you don't know anyone that has already paid for that.
Okay. There is no encryption from a account key or something like that.
They could, but because it's running on the device, you can decrypt it. And at some point in memory, it's decrypted. And most of the time it's in Java, so it's super easy in theory. You write a hook when they have finished decrypting the level, and then you get your data, and then that's it.
Okay, thank you.
That's it.
Any more question? No? So we can thank Jeremy.
Yeah, maybe just a bonus section. So when you want to do hooking, it's a bit annoying because each time you redeploy a hook, you have to restart your emulator, and you see with Android 8 it can get really slow. So what you can do with JADEX, so you get the Java code, you can export that to an Android Studio project, but it won't compile because you don't have the Android dependencies and it's pseudo Java code. It's not exactly the same application because it's reversed, but what you can do, you can edit the manifest file and you say, hey, my application, the debugger flag, I set it to true. You resign it. You deploy your application in your Android device, and then now you can put breakpoints from Android Studio, so you see exactly what's going on. And this is really, really, really super convenient. That's it.